During most part of the modern era of the automotive industry, the standard was an ECU-centric architecture. The car had hundreds of ECUs, each dedicated to one specific task, and the focus was on hardware improvement, so it had a better engine, a better transmission, or a better suspension. This of course had its limitations. Once the car left the factory, the software was frozen, and the only possibility to update was either through a recall or a manual software download. But it's important to remember at that time those vehicles they had close to no internet connection, so it was impossible to have cloud features or even real-time data analysis. But with the rise of advanced computer, artificial intelligence, and especially with over-the-air updates, it started a change on the automotive industry, going from hardware-centric to software-centric standard. Software-defined vehicles (SDV) is a modern concept where all the functionalities from the car are controlled and updated via software rather than being fixed by the time they were manufacturing. This concept is very similar to how smartphone works, where through software updates you have new functionalities and the smartphone capacity is enhanced. But when we talk about SDV, we need to highlight some key factors. The first one is the basis for SDV, which is the over-the-air updates, which is how the card can receive the new software remotely. Also, we have the decoupling from hardware and software. Now we don't have the hardware limitation, so through the time we can have new functionalities added via software. Something that is intrinsic to the over-the-air is the enhanced connectivity. This is one of the centric parts of the software-defined vehicle. Through cloud computing and real-time connectivity, you can have updates on the navigation system, you can have real-time diagnostic, and even artificial intelligence assistance. And another change that was introduced through the SDV platforms was the centralized computing architecture. Instead of having multiple ECUs performing different functions, SDV moves towards a centralized compute architecture, reducing complexity and improving efficiency. Now, the next two are more consequence of the SDV architecture. First, we have the enhanced cybersecurity. Now you have a connection to the exterior world, and that is of course an open door for cyber attacks. For SDV to exist, we had to implement better cybersecurity protocols and algorithms to prevent hacking and ensuring data privacy. And the second one is the born of the autonomous cars and the ADAS features. Maybe throughout my explanation was clear the benefits of SDV, but I think there are some that's important to highlight. We have the continuous improvement that now the software can improve throughout the time rather than be frozen. Cost efficiency that now you don't need a recall to fix issues on the cars, and better maintenance. And if we think about the future of the automotive industry and how SDV fits on all of that, it's definitely moving towards fully autonomous cars, personalization through artificial intelligence, subscription based and on demand features, and in my opinion, the biggest change is on the business model. In the end, the car will be just a platform where the OEMs will sell their software. And if we think about us engineers, that is probably the best opportunity in many years in the automotive industry, because now we have more and more positions for software driven engineers, not only hardware engineers. My name is Jose Gomes and I am an automotive engineer. And if you like this type of content, you can follow me in my other social media. And let me know in the comments what you think about the software driven vehicles and the future of the automotive industry.